Hello everyone. TechGoodReads give you good thing to read to listen. Welcome to today's TechGoodReads. Today I will talk about big data. For the concept, big data is where parallel computing tools are needed to handle data. Big data means that the data outgrows your ability to process. Usually we consider several factors that the data volume, variety, velocity. These three are most common criteria that measure the data. It belongs to the big data. But after that, people extended to 6 V's of the big data, including veracity, value, and variability. Why we need to handle big data? Because with such a big data, we can answer questions. And this answering can help you create competitive advantages. When we handle big data, we usually use a data pipeline. We use the step collect, process, and analyze, and then visualize. These 3 steps to create that data pipeline. From the right side of picture, we can see this picture that when the data is injected or collected, we first put into the storage, and then we process it and analyze it, and then this data can also be storage or just put into the visualization. After we have some insight of those data, then we can use this drive our business, and then maybe more data we need to collect. So that data pipeline will become a circle. To handle such a big data, here's the architectural principle. We need decoupling storage from process by data bus and enabling parallel processes. It means when we get data, we first store and then process. After processing, we store again, and then another processing. And at last, we have answers. We can see it's just the alternative of store and process. Using such a data bus or data pipeline, it can help us build a very robust infrastructure. Many tools and cloud computing tools have the data lake concept, and this is widely adopted for the company. AWS also provides a data lake infrastructure. A data lake is a centralized repository that allows you to store all your structured and unstructured data at any scale. From the right side picture, we can see that we can collect different sources of data like IoT, S3, log files database, and put all those data into the S3 as a storage. Or maybe we can also use Redshift as a storage. We can use EMR to put the data in and out and do some computation. We can also use Amazon Glue as the ETL tool to handle those data. After we process it, we can use Amazon SageMaker to do some computation based on those data, like machine learning, do some prediction. We can also use Amazon QuickSight to visualize those data, to generate a report or dashboard. From the concept, we have a data lake and a data warehouse. They used a little different. Here's the comparison. For the data warehouse uses relational from transactional system, operational database, and of business applications. And the data lake is a non-relational and relational from different resources like IoT and websites. The main difference of the data warehouse and data lake is that schema. For the data warehouse we designed prior to the data warehouse implementation. This means that it's a schema on write. We need to prepare the schema beforehand. And for the data lake, we only written at the time of the analyze is the schema on read. So due to this, we can see that for the data warehouse, the data is relational and is ensure that the data is high quality. Then we can also use that the data warehouse is sorted the keys, so it have much better performance. But for the data lake, it's designed to handle different sources of the data. So the data format maybe contains video, audio, or that relational data, but the formats are various. So we cannot handle them beforehand, but we will handle them after that. So any data can put into the data lake. And this we cannot build an index on it, and the speed is slower than the data warehouse. This means that we use data warehouse build repetitive tasks, and for the data lake, we do some research and maybe one-time tasks on it. Thank you for listening. This is Chinese. See you next time.